Okay, so this is an example of putting an extended wait capability into a state machine that's running relatively fast. This is running at 25 milliseconds per loop, which is pretty quick, but we want to have a 2-second delay in our 90-degree turn state machine. So what it boils down to is we want to turn 90 degrees and then we want to wait 2 seconds before we accept another button push. And so what I've created, and honestly I just rebuilt the whole thing rather than trying to cut and paste, a state machine that has 5 states in it, with the last or the added state being the 2-second delay. And I've incorporated a parameter that I create before I go to that 2-second delay. That is the time limit for each time I use it. And so here's how this works. Again, in my initiate state, I want to set everything to 0 and go to the wait state. When I'm in the wait state, again, I have, when everything's quiescent or static, I have the system sitting there waiting for a button push, and the motors are quiet, and the reset gyro is not doing anything. Now, once we go to either button on or off, just like before, we go to that function, we reset or that state, we reset the gyro, and then we go ahead and go to that particular state. While we're in that state, we're looking for the gyro to change an absolute value to a number greater than 89. And as we do that, we're making a turn that's determined by the polarity on these motor drives. And consequently, we know if we're going left, we have to go backwards on the left motor and forward on the right motor. Now you'll notice nothing's happened to this parameter that I've set up here. And I will put a label on it just so I remember what I did this for. And frankly, it's a good idea because after this is rested for a while, I may forget. All right, so nothing's changed up until this point, except when I reach the 90-degree point, I want to go to that 2-second delay. And so to do that, I have to create a parameter that's called my time delay, and it's based upon the current tick counting. This is a more precise time measurement based upon milliseconds. And so I'm going to create a future time limit of 2,000 milliseconds in the future and put it into this particular shift register. So now when I go to 2-second delay, which is the next state that we've indicated, we start looking at that parameter. And we compare that parameter that's static against the tick counter that's timing the current tick clock on the processor. And if it's not exceeded that time yet, we stay in the 2-second delay state. Everything is static as far as our wheels and our reset. And now we stay in this mode, although we're releasing the processor every execution of the while loop until the current tick counter exceeds that future state, the future time limit. And when it does, then it goes back to wait and we're all done. So if we try to do this, what we expect to see, I turn this on, and we're in the wait state. We start the left motor drive and the right motor drive looking for a 90-degree change. So if we go ahead and increase there's 90 degrees. Now it should not respond to a button. It did. And so I need to go back and find out why I didn't respond to my 2-second delay. So let's kind of look at this. We do a 2-second execute. Okay, we're at 88 degrees. Now you can see my delay doesn't matter except for in the right turn. So if we set our gyro now to greater than 90 milliseconds, we're at 22 degrees right now. We go to 90 degrees. It should recognize it, which it did. Now it's going to go to my 2-second delay. There's 87,000 number. It's coming through. We went to our 2-second delay, and we're waiting. And at that point, we exceeded the 2 seconds. So that part looks like it's going to work fine. Back to wait. Go ahead and reduce our count. Let's see what happens with the button push on. Now you notice with this, I have to have the signal existing when it goes to this particular stage. So I don't want to release the button until it's recognized it. Okay, there's the button's true. We go into the right turn. We're still false. We haven't exceeded the 90 degrees. Let's turn 90 degrees on. There it is. Now we go to our 2-second delay, 87,000 something. And it went back to wait. So it looks like it's working. We'll see if we have a problem real time. And what I'm looking for is under my turn signals, 2000 is enough of a delay. So let's go look this up. So I'm using context help, and I see that the tick count returns a value in millisecond timer. So if I add 2000 to it, it should give me a signal that's 2 seconds in the future. So I need to work on this a little bit more. All right, hopefully this helped. And if I discover where my problem is, I'll issue another video. Yeah, on further examination, I put in a indicator to show what state I'm in, and it's staying in the 2-second delay just fine, just quicker than I expected. So real quickly, I'm going to start a left-hand turn. We're going to exceed and so what we're watching is my enum indicator. We're in a left-hand turn. We get above 90 degrees, goes to a 2-second delay and waits. So if we want to see that take longer, let's put a 5-second delay in there and make this 5 seconds, 5,000 milliseconds. And that has to be in both my left and right turn case structure. And then we try this again. Okay, so we go right turn, reset the gyro, start the turn, motors are running. We go above 90 degrees, went to our 2-second delay. It takes 5 seconds. Now we're able to respond. So we want to try this again, see if we can make it respond while we're in the 2-second delay. So we're in the 2-second delay, and it didn't let me respond, so I was just slow on the trigger. Okay, hopefully that helps.